All right, everyone. In this lesson, we're going to use what's called a window note to help us analyze word problems and to figure out how to set up our dimensional analysis problem. So in our previous videos, we have done one-step dimensional analysis problems using Avogadro's number and using molar mass. And so we're going to use this to kind of help us break down our work and understand how to solve the problems. So in this case, it says Americum, which is AM on the periodic table. It's number 95, and it's on in the F block underneath the main part of the periodic table. It's an element that does not occur naturally. It can be made in very small amounts in a device called a particle accelerator. Compute the mass in grams of a sample of americum that contains 3.78 times 10 to the 12th atoms of americum. So what we need to do to solve this kind of problem is we need to know a couple of things. What are the facts, meaning what's given to us in this problem? The conversion, so what conversion factors are needed to solve this problem? What's the question? So what are we trying to find? And then what's the diagram or our t-chart? How can we represent this problem visually? And so we know that the facts, so what is given to us? We know that we are given the fact that we have 3.78 times 10 to the 12th power atoms of americum, which is AM. And for our conversion factors, well, we know that if we have atoms in what we're given, that we're going to need Avogadro's number. So Avogadro's number as a conversion factor can be written as 6.02 times 10 to the 23 atoms of americum over 1 mole of americum. And if we need to. But is that the only conversion factor we need? Well, in order to fully answer that, we also need to know what our question is. What are we trying to find? Well, it tells us to compute, which also means to calculate the mass in grams of this sample. So that means we need to know the grams of americum. That is what we're looking for. And if we have grams, that means we also need molar mass. So atoms tell us that we need Avogadro's number, but grams tells us that we're going to need our molar mass, which since this is an element, we can look at the periodic table and find out that the molar mass of americum is 243.06 grams of americum, and it's going to be equal to 1 mole of americum. Or we can flip it. And again, this is our molar mass, which I didn't write above it. Okay, so we have two conversion factors that we're going to need. And since our elements are the same in both our facts and what we're trying to find, then we don't really have to do anything. But here, in order to solve this problem, we're going to need two different conversion factors. And so how do we set up this problem visually? Well, we know that our visual representation of the dimensional analysis is with a t-chart, okay? And we take what's given to us, or our facts, and we put it in our chart first, which is 3.78 times 10 to the 12th atoms of americum. Now, when we put this in our chart, because we have atoms of americum in our numerator, that means we're also going to need atoms of americum in our denominator. Now, when we look at atoms is only in Avogadro's number, but the way we have it written right now, atoms is in the numerator, and we need it in the denominator. So that means we're going to have to use the flipped version of this. So we're going to put 6.02 times 10 to the 23 atoms at the bottom and the 1 mole of americum at the top. Now, this is good because what it does is it allows atoms of americum to disappear. It cancels out when you have it in the numerator and the denominator. But moles of americum does not match what we're trying to find. So what we're going to need to do is we're going to need to use a second conversion factor to actually get to grams. I'm going to draw that a little bit neater. All right, so what we know is that we have moles right now, and because moles is in the numerator and we don't want it there, we're going to have to put moles of americum at the bottom. Now, we see that Avogadro's number has moles of americum at the bottom, but we've already used Avogadro's number one time, so we can't use it again. But if we look, molar mass also has moles of americum in it, and it's already in the denominator, and it has grams at the top, which is good because that's something different. So if we put 1 mole of americum at the bottom and 243.06 grams of americum at the top, we can see that moles of americum is in the numerator and denominator, so it will cancel out, and grams of americum matches what we're looking for, so that means we're ready to put things in our calculator. And just like with one-step dimensional analysis, when we do this, we multiply by what's in the numerators and we divide by the denominators. So when we put this in our calculator, we can say 3.78 EE12, because I use the EE function. If you're not using the EE button, then you need to put your number completely in parentheses. So times 1 times 243.06 divided by 6.02 EE23 divided by 1. So we multiply by all the numbers that are at the top and we divide by the numbers at the bottom. Just keep in mind that this number that goes in your calculator first must be your given. Anything else can really go in any order whatsoever. So when we put this in our calculator, we get 1.526, which since this has 3 significant figures, we're going to need 1.53 times 10 to the negative 9, and our remaining units are grams of americum. And so that will be our final answer. And so what I want you to do, whether you're in class or at home, is I want you to do the second problem on your own. One thing, though, that I want you to keep in mind is that here it says our sample is 1 kilogram. Now, a conversion factor that you might have forgotten about is that 1 kilogram is equal to 1,000 grams, and you might need that in this problem. And actually, I wrote that as an equality, so make sure that you put that as a fraction on your work. So go ahead and work on that. But this was an example of a two-step dimensional analysis problem because we used both Avogadro's number and molar mass in the same problem. If you want to see some other problems worked out, you can come to tutoring, ask in class, or there are lots of other videos on this YouTube playlist that you can check out.